Hi, today my group will be conducting a simulation study on the subject PN junction. First, we'll be assessing the NanoHub website, which is an open source simulation tool. So first, we'll be assessing the resources. Scroll down towards Tools. In the Tools side, let's find Abacus, and we will start the simulation by launching the tool. We will choose PN junction lab. We'll start with the structures tab. For the first set of inputs, we have 3 micrometer for the p-type and 6 micrometer for the n-type. Next, we need to choose the capacitance against the gate voltage characteristic graph. You can see here we have got the first set of inputs graph. Next, for the second and third input, we will change the p-type and n-type length. So once we have set the 3 sets of inputs, we will move on to display all of the 3 simulations. Well, when click at the first simulation, you can see that from the graph we have the highest capacitance against gate voltage graph. For the second simulation, we have higher p-type length 9 micrometer and n-type length 12 micrometer. It has a lower graph compared to the first graph. For the last simulation, we have the highest value of p-type length and n-type length 50 micrometers and 20 micrometers. You can see from the graph we have the lowest graph compared to the first and the second. When the p-type and n-type length are the highest, the capacitance against gate voltage graph will be the lowest. Well, this is the first simulation, the structural properties of the PN junction.
So now I will be explaining about the material properties of the PN junction. So there are 4 types of material, but I will just consider 3 of them, which are silicon, germanium and gallium arsenide. So now we will proceed with silicon first and we stimulate it. Select energy band diagram to determine the result. So the energy level of the conduction band is 0.815 electron volt for silicon. So now we proceed to germanium and we stimulate it. For germanium, the energy level of the conduction band is around 0.45 electron volt. And for gallium arsenide, the energy level of the conduction band for gallium arsenide is around 1.219 electron volt. So we can conclude that different material will have different energy band level. So among these material, gallium arsenide have the highest band energy, followed by silicon and germanium. So highest energy band in gallium arsenide indicates that more energy is needed for the excitation of electrons to occur compared to silicon and germanium.
Okay, next I will show you the effect of temperature on PN junction. I will do the simulation on NanoHub. First you click the environment tab and then you can set the temperature here, which I set to 300 Kelvin room temperature, and I simulate it. Okay, the diagram shown here is current versus voltage. Before that you need to repeat the step on 300 and 400K and 77K, and then you need to click a button here, all, which will bring you to this diagram. This one I did earlier. So okay, when the temperature is 77K, you see that the current couldn't pass through the PN junction. The graph is a linear graph which is at 0 current, and when we increase to 300 and we increase to 400, you will see the current also increases. Okay, this is because PN junction diode parameters like reverse saturation current, bias current, reverse breakdown voltage and barrier voltage are dependent on temperature. The rise in temperature generates more electron hole pair, thus conductivity increases and thus increase in current. Therefore, if we kept the voltage constant, as we increase temperature, the current also increases.
Okay, so in conclusion, using the NanoHub, we have stimulated the PN junction in 3 different categories, which are material properties, structural properties, and temperature. From the graph obtained, gallium arsenide has the highest energy band, followed by silicon and germanium. And besides that, the lower the width of both n-type and p-type material, the higher the capacitance to gate voltage in the semiconductor. And lastly, when the temperature increases, the conductivity of the PN junction will increase as well. So that's all from us. Thank you.